Yes.
Okay. It's my pleasure to invite for keynote lecture Professor Елена Зайцева, University of Žilina, the Slovak Republic. Professor Елена Зайцева works at the Department of Informatics of the University of Žilina, the Slovak Republic. His research interests include mathematical methods in reliability and safety analysis, classification problem, and algebra logic-based methods application in reliability evaluation of complex systems. She is author of more than 100 articles. She has led international and national projects practically related to reliability analysis and its use in applications such as information technology, healthcare, and ecology. She is a member of Technical Committee of European Safety and Reliability Association and the chair of Reliability Association.
One second.
Okay. Sorry for some technical problem. This situation illustrates that really we need to consider is not only system in as binary systems that work or fall. In this situation, we should be consider a system as multi-state, because between complete fault and complete function there is some state. And we can improve situation for system reliability, analyze the situation if used multi-state system. And if we consider multi-state system, we need to decide how we can present it, this system mathematically. There are some methods, some mathematical representation for multi-state system. And there are some methods which allow us investigate system based of multi-state system as mathematical model. Of course, it's extension of binary models for case of multi-stage system. It's a stochastic process which adopted and used for multi-stage system analysis. First of all, it's a Markov model. And next is a universal generation function, very often used for analysis of multi-stage system, Monte Carlo simulation, Bayesian model, etc., etc., etc. All method of mathematical representation used for binary state system plus or minus can be used for multi-state system. But we propose used for analysis of multi-state system extension of binary model to a multi-state system, multi-state system case. Between all of this extension, we first of all consider mathematical representation of system based of structure function. Structure function have close correlation with decision diagram, algebra logica based method, reliability block diagram, multi-state diagram, and other. But first of all, if we say about all of this representation of structure function, we need understand what is this structure function, how we can present it, this mathematical model. If we consider on a structure function or definition of structure function, its function can be defined by this mathematical expression. This expression maps all combination of component state to system state. For more exact definition of conception, we say that component have state and system have performance level. So we can consider the structure function as maps of all combination of component state to performance level of system. And if we want to consider multi-state system, and we say that it will be considered as extension of Boolean method, we need to decide next problem, the problem of dimensional, because if we used more large system for more detailed representation of system, is as rule extend the dimensional of mathematical model. We need new method, new algorithm for evaluation and computation of indices for reliability, and we need designed problem of uncertainty. About this problem, I say somewhat, especially in this presentation. If we say about first two of this problem is problem of dimensional of multi-state system, and needs to develop new method and algorithm for analysis of system based of multi-state system. We don't have to use Boolean method, and we can be able for this problem other method. It's method of multivariate logic. Typically, in reliability analysis for multi-stage system used Boolean method, but it's not effective, and more effective used multi-evaluate logic method. And if we want to consider the problem of uncertainty of data in a multi-stage system, we should use machine learning methods. So all principal problem which there are in application of multi-stage system, we can decide based of multivariate logic and some of method of machine learning. Let me introduce more detail this problem and illustrate what mean problem, for example, in interpretation application of multi-state system for reliability analysis. In this slide, we can see a very simple system. It's parallel system of two components. If we will use the binary state system, it's our first table. In this case, we have only one representation of this system. It's very well now Boolean function or. But if we will consider multi-state system, we have numerous representation, mathematical representation of this system. The two first table illustrate that we can indicate different number for component state. In the first table, we have only two state for component. In the second table, we have for second component three state. It's different mathematical model in different result in point of view of reliability analysis. And last two table have a similar number of state for component, but it's different mathematical representation in different system in point of view of reliability, because functioning of this case is defined by a different way. It's the first problem which we need to decide with application of multi-stage system. So it means that it's not enough only define typical structure as, for example, serial parallel system. We need exact defined mathematical description of system in terms of multi-state system. But previously, I say that for analysis of multi-stage system, we can use method of multiple evaluate logic. Of course, it's possible, but we need to decide before this application a very important theoretical problem. If we consider structural function of multi-stage system, it's, for example, you can see example in which the first component have two states, the second component have three states, and system have three states in its behavior. But can we such function interpreted as a multi-state system? Typically is not because definition of multiple evaluate logic you can see which defined by this expression. What the principal difference between structural function and multiple evaluate logic? Principal difference that in a multiple evaluate logic we have equal number of value for all variable and value of function. In structural function is not necessary, and it should be decided. To decide that problem, we can introduce for in point of view of theoretical aspect, we can introduce is not a specific state for our structural function. It's we consider such function in term of multiple evaluate logic, this function can be interpreted as multiple evaluate logic. It means that all method that can be used for multiple evaluate logic can be used for analysis of structure function. So problem that correlation between multiple evaluate logic function and structure function can be decided, and we can use all method from multiple evaluate logic to analysis of multi-stage system in reliability analysis. But next question, next problem, what need consider. It's a problem that how we can propose interpretation of structure function which we use. Previously, in previous slide, it was indicated as table definition or analytical definition, but there are one more interpretation of structure function. It's very important for application in definition, for application method from machine learning, for definition problem of uncertainty in data for development structure function. Is interpretation of structure function by classification structure. It's really, if we consider this table which presented in this slide, and one interpretation of structure function, but we can present it this structure function as a classifier which divided all state into in three classes. One class is 0, it's agree with state when system fall. The second class is marked but 1 in state when system have some functioning, and last class is state for perfect functioning of our system. So if we have some uncertainty, for example, in our system, for example, we have no definition for two state. How we classify, indicate this state for a description investigated system by multi-state system or other mathematical model, we need interpreted this state by some of method. Of course, here we can end in other type of uncertainty. Is not only incompletely specified type, but it can be introduced the uncertainty as vagueness ambiguity, which don't allow us exact indicate that this state is perfect functioning or partly functioning. It's Bodin definition in interpretation of system state. To cover this problem of ascendantly interpreted ascendantly in term of mathematical model of multi-state system, we need to introduce some correlation between classifier induction and conception of reliability analysis if our system represented by multi-state system or structure function. In this table, it's indicated this correlation. In this table, we can indicate the number of components system can be interpreted as number of input attributes. System component can be interpreted as input attribute for induction of classifier. The system performance level is interpreted as target attribute or output attribute, and values of this is attributed. We can interpret it as component state or system performance level. And generally, structural function, we can interpret it as a decision table, which can be elaborated based off any of classifier. The typical typical method for development of structural function or mathematical model in form of structural function for multi-state system, we can present it by 3 steps. The first step is data collection. We need to collect data. It's can be observation or expert evaluation, and based on this data, we form a data set which is acceptable for classifier induction or classifier development. Second step is
Sorry, we know you lost the image for a point, but did you also lose the sound? The colleagues online? Can you hear us online?
Yes.
Did you lose the sound for a period or just the picture?
okay. Let me continue. Do you hear? Do you see the share screen?
Yes,
Okay.
please.
Okay, let me introduce some example of application of proposed approach for reliability analysis system by application of multi-state system as mathematical model and taking into account the assessment which we decided by method of machine learning. For example, we have drone fleet, drone swarm, and we have only some observation for about this problem. Only for some drone we have defined it as state that functioning or no, and loss state were added by expert evaluation. So for each state in this table, we have two values. One value is the drone or component of swarm or drone is functioning. The other is a fault. For each of these states indicated some possibility of this state. These possibilities we interpreted as further values. Based on this table can be developed the fuzzy decision tree. It's, for example, presented for this data fuzzy decision tree. And this fuzzy decision tree by depacification and rules of transformation decision tree to decision diagram can be obtained multi-value decision diagram that without problem can be evaluated for definition indices of drone swarm reliability. In particular, if decide such initial data, compute, for example, Beerbaum importance, availability of this swarm or unavailability of the swarm. If we consider, for example, availability of this swarm is not very high, and we can propose some modification changes other type, and if we introduce drones with higher reliability, we can the second example of application of this method is importance analysis of input attributes in problem of prediction some values. In particular, it was considered for this problem in health care. It similar work for attribute selection method, and if say in more detail, it's combined with embedded method of attribute selection. And last example of application of this method is not typical application. It used this method for human reliability analysis, in particular for evaluation of medical team work and definition more important person who have a must impact for medical error. Because time is shorted, I show only result. This table was format based of decision tree for this problem, and for this team we defined state of performance level of this reliability, and we can see that fatal error is no very possibility for this team. It's so good. But next step in this problem was the definition proposition for improve work of this team. And if we consider this diagram, in this diagram was proposed introduce to some equipment and introduce in system application of system by some equipment really improve the possibility of perfect care for patient, and it's a good result of this analysis. If say generally of proposed method is method for combination of machine learning as classifier induction and multi-level logic. In particular, we use a method of multi-level logic for importance analysis in analysis in calculation indices of reliability. Last remark for my presentation is introduced for your intention workshop, which will be correlate with thematic of my presentation. This workshop will be premier in months. Participation is free without any organizing fee. This workshop online, and you can join, and maybe anybody want to participate is possible too, because deadline for abstract submission will be in 2 weeks. After this workshop will be published of Springer of selected presentation, and welcome for this workshop, and thank you for your attention for presentation of application multi-stage system in the reliability analysis.
Thank you very much. Sorry for some technical problems. And now we have very short time for questions and answers. Welcome.
Did you consider this problem as discrete optimization problem? For example, could you show us an objective function, constraint, and so on?
I understand your question. Unfortunately, we don't use now optimization problem. Is really we near this decision this problem because really it's need for some of application, and it's next step.
Because this is a project very close.
Yes.
Thank you. Any other questions? Okay, very short question. We can consider this system as multi-state systems with multi-state components.
It's not necessary. It's possible, but it's not necessary. We can define for component state a different number of states. It can be two state fault or function. It can be most. It's not important. We consider multi-state system if one of element of system, components or system have more than 2 states.
Yes, because it would be very interesting for UAV swarm when you can consider separate UAVs as multi-state system and multi-state system. So, thank you. Thank you very much. Dear colleagues, now we have finished our morning plenary session. Now it's time for coffee break. And after that, I